Hello viewers, welcome back. In this video, we'll discuss about analog output scale, or we can call analog unscale. Suppose we have a actuator and that actuator controlled by a pressure, and that pressure also controlled by analog output, analog signal 4 to 20 milliamps. Here we can see that a picture Siemens farid controller, I2P controller. That input is current I and output is P, pressure. Here input analog signal is 4 to 20 milliamps and output will be the range of your pressure input. If the pressure input is 5 bar, then output will be 0 to 5 bar, and that 0 to 5 bar will control the actuator. And to control the actuator, this I2P converter, we need a analog output signal, and that signal we will take from the analog output. Here our control signal type is 4 to 20 milliamps, and you know that Siemens we already discussed in analog scale block, analog scale video, that for Siemens used 4 to 20 milliamps against 0 to 27648 value, or any other analog signal like voltage signal. So for 4 milliamps integer value is 0 and 20 milliamps integer value 27648. Here we are using a actuator I2P converter to control the actuator. So here our input signal input is 0 to 100% from the HMI, and that 0 to 100% will convert from by the program, and that program convert 0 to 100% to 0 to that integer value, and that integer value sent to analog output channel. So physically we will get the 4 to 20 milliamp signal. So our set point, as I told, that our set point is percentage here, and that will done by 3 steps, that we will give the set point from HMI as 0 to 100%, and intermediate stage will convert that 0 to 100% as a integer like this, and that integer value will send to the analog output channel, which will give a analog output control signal 4 to 20 milliamps. And we can do that scale, unscale or scaling analog output scale by 3 ways. One is using the linear line equation, another is the scale x norm x, and another is we'll use the HMI scaling function. So we'll do that 3 method. Today we'll use the linear line equation. As you know, the linear line equation is that if we know the 2-point value of linear line, then we can find the third point output value if we give the other value. Like if we want to find the y value if we get the x value. So here linear line equation is y equal to mx plus c. M is the slope, and that is y2 minus y1 divided by x2 minus x1, and c is called the intercept value. If the line is not intercept in origin here, like here it is intercept here, then here c will be 0 to that value. When the x value is 0, that time c value is here, or sometime this value on this line can intersect like there. So y value, c value can be positive or negative. For this case c value is 0 because it intercept in origin point. So we can tell that y equation like this, but we will use the c value in our function. Here I will write something more, that for analog for analog input, our input was 4 to 20 milliamps, and that 4 to 20 milliamps used as a 0 to 27648, and we convert that integer value as a physical value. It can be a motor current, it can be motor power, it can be level, it can be pressure, and that value was a real value, means the decimal point value, floating point value. But for today we will discuss about analog output. So here our input value from HMI, is real, because if the set point is here, we will use 0 to 100%, because sometimes we may give the 23.5 or like this, any value. So here input is our real. So data type is real. Input is real. Intermediate program which will convert that input from HMI to 0 to 27648, and that converted value is a integer. And that integer value, if we send to analog output channel, then physical output control signal will be 4 to 20 milliamps. So we will send that integer value to analog channel. Okay. So here our equation is, okay, later I will write this one. First we'll add the analog output module. Here from that device configuration, I open the device configuration, that device view. Here I will add the analog output channel, and here you can see that output is U/I, means that output module will give the output voltage or current, not the resistance or any other signal. So here I will take 8 in output module, 8 channel output module. Now I will double click. Here you can see that the startup option will taken from CPU. We already configured the CPU. Okay, here you can use the template, that if you use the template, all channel setting will be same if you set here. Okay, here you can choose some diagnostic, but if you use that diagnostic button here, option here, you have to use the OB82 and program there. From here we already take the diagnostic error interrupt block, but we will not program right now. And now I will deselect all the option, only we will select the output parameter type, that our channel output will be current signal, and the output range plus minus 20 milliamps, not plus minus 20 milliamps. We will use 4 to 20 milliamps. Here is the another option is called that reaction to CPU stop. If in any case your CPU is stopped, that time your output channel will be shut down, or you can keep it to last value, means your CPU is stopped, but before the stop your output value was 50%, means 12 milliamps. You can keep it like this last value. So your CPU will stop, but output will be for 12 milliamps constant. Or you can use substitute value when CPU is stop or fail in any case. And that is very important when the process very sensitive, that if your damper need to open 50% or 60% in any failure of CPU, then you can use the last value or substitute value. Okay, here I will use as a last value. Okay, then you have to set the IO address. Here it is already taken the start address as a 4, but I will use 300 because before the 300 we can use the digital signal. If you use here as a start value 4, then if you add another digital output module, then it will take the next of that analog output address, and that will mix the analog output, analog address and digital address. So I will separate the 300. So before 300 we use the digital signal address. Okay, now I will simulate, I will compile. Okay, now I will add a function block, that add a new block. I will use it as a analog Unscale and use as a SCL language. That okay, before we will write the program here, I'll go back to the paint. That equation was y equal to y2 minus y1 and x2 minus x1. Here y is output, x is input. So I have told that our input is from the HMI, that 0 to 100%, and that is real. So here y equal to y2 minus y1 divided by x2 minus x1 plus multiplied by x, right? So here y2 equal to y is data type. Here data type, I am writing the data type. So y2 is output, and that is integer, this one, and integer. Y1 also integer, and x2 is our input, that input high range, that is 100%, and that is real. x1 also real, right? Also C also real. Okay, here also you can see that intermediate value input is range is 0 to 27648, and that is constant value, and it is a integer. So we can only we will use the input as that y2 range, that range is constant range 0, y2 is 27648 and y1 is 0. So we will not define any input of that y2 and y1. Okay, here I will use the in, and that is x, you know, and it is real data type, and in high range is real, in low is real, but we will not use the output range because it is constant, and here is our out. Okay, our equation will be out and our output is 27648 y2 minus y1, right? Our y2 value is 27648 minus 0, right, divided by x2 in high. So here this is a x2 value in high, and this is a x1, and this one is y2, and this one is y1 in high minus in low. Okay, I'll bracket another one and multiplied by in x input random value from the HMI, random value from HMI. Okay, here you can use the C also. Yes, I am missing something, that is this one is our integer value, but I am writing it as a here. Okay, now that is our small equation, linear line equation. Okay, but here is a error, that is called the block call was invalid because interface was changed in the meantime. Okay, okay, that is our small that is our small linear line equation. Also you can add C here also. Okay, so for now C is 0, but you can use C for other input also, so you can keep C here. Now I will call the analog scale function in main OB1. Okay, and here I will use the address PQT because our first input is address, first output address is 300. So here I will use the address. Here you can use the IO tag also, that here you can use the actuator set point. Okay, now here you can use PQW, that 300, and that is actuator SP. So here here in intercept value is 0, in low is 0.0, but out is in high is 0 to 100%, so 100%, and I will use a tag, that db1, that is actuator the set point real. Okay, now I will use that set point here, db block 1 set point here. Okay, I will use that set point from the HMI. Okay, I will open HMI, that is skin 2. Okay, still it is not here. So here I will use that element, from element I will call the, okay, now from the general I will call the tag from the program block, that one set point. Okay, decimal. Okay, now I will download first CPU program. Okay, sorry, it's already the Okay, now I will simulate HMI. Okay, now I will go that page here. That one I will go. Okay, now from that HMI I will set 50%. So enter. See, that value is 50%. I have set from HMI. The output is 13,824, means it is 50%. So because I have used QW300, that is a output analog channel address. So physically if you measure the millions from that channel, you will get 12 millions. If you use 100%, then output is 27648. If you use 0, that output is 0. If you use 10%, so that is 276,865. One thing you notice that here the yellow line under the equation, and it's showing when the data compatibility issue is there. Here out data type is integer, but the calculation value will be real value, because this in high, in low is real, in value is real, and that one is integer, but multiplied and dividation, it will be real value. So we have to convert the data, that real to integer value as the output. Here we can use the real to integer equation, then give a back in here. Okay, now there is no error. See, there is no error. Okay, thank you. In next video we'll see how we'll use the normax and scalex function. Later we'll use the function HMI scaling function without using that analog scale block. This one we will not use that analog scale block or any normax or scalex. We'll use just that set point, how we can use the scaling function in HMI. Thank you.